Hello, listeners. As an enhancement to your listening experience, I am now going to present these archive episodes unedited in their entirety, which includes all of my afterthoughts. So, continue listening after the outro music if you want to hear what I thought of the episode. And if you are enjoying the podcast, please support it by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. And now I can also accept Zelle and Venmo. Just use my email address, spacerockethistory@gmail.com. Thanks.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Getting my gear on. Okay, I'm on.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Listen, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 235 of the Space Rocket History Podcast. And now, Apollo 12, Introduction. When the crew of Apollo 11, Armstrong, Aldrin, and Collins, were released from quarantine, President Richard Nixon had them and a few hundred guests out to Los Angeles to celebrate. By most accounts, it was a great party. Sometime well into the evening, one of the other astronauts in attendance, by now a little drunk, raised his glass and heartily said, "Here's to the Apollo program. It's all over." In a sense, he was right. John F. Kennedy's challenge to land a man on the moon and return him safely to Earth, the goal that had steered NASA for 8 years, had been met. But was Apollo's mission really over? Was the lunar landing simply an engineering demonstration, like the first flight across the Atlantic? There were those who thought so, even some within NASA. Kennedy had said nothing about a second lunar landing or a third. You wouldn't ask Lindbergh to fly the Atlantic again, they said. Why go back to the moon? But in the summer of 1969, Apollo was only part of a much bigger question. The future of the space program as a whole was undecided. When Richard Nixon took office, the agency had tried to gain early support for a manned space station in Earth orbit. But the president deferred the matter by creating a space task group to formulate recommendations for NASA's future. By July, NASA Administrator Paine was working with Nixon's Space Task Group on a plan that picked up where John Kennedy had left off. Paine, like his NASA colleagues, believed there was something implicit in Kennedy's challenge beyond its words, that it was a call for the United States to become a spacefaring nation. Apollo had given the country the technology to go to other worlds. The country should now exploit that capability. At NASA headquarters, George Mueller and other planners had created a far-reaching plan that Thomas Paine made even more ambitious in adapting it for the Space Task Group. The task group timetable called for a 12-man space station and a reusable space shuttle as early as 1975, depending on funding. By 1980, the station would have grown into a 50-man space base. 5 years later, there would be 100 men in orbit. Meanwhile, there would be a base in lunar orbit by 1976, with a base on the lunar surface 2 years later. Then, As early as 1981, the first manned expedition to Mars would depart from Earth orbit. The plan was extraordinary, but it was not new. Almost 20 years earlier, the same basic scenario had been mapped out in the pages of Collier's magazine by Wernher von Braun and other space experts. At the time, von Braun was criticized for trying to sell the public a science fiction version of the future. In the summer of 1969, Thomas Paine was trying to turn von Braun's vision into reality. Like everyone at NASA, Paine hoped that the spectacular success of Apollo 11 would create a groundswell of support in the White House and in Congress to propel the space program onward and upward. Fortunately, Vice President Agnew, the chairman of the Space Task Group, was extremely enthusiastic, especially about the missions to Mars. The group report would be ready for presentation to the White House in September, but already there were signs it would not be well received. Since 1965, the year Apollo's funding reached its peak, NASA's budget had steadily declined. President Nixon's staff had told NASA that this trend would continue and indicated that even the first building block in the Space Task Group's plan, the Earth orbiting space station, would be a tough sell. Meanwhile, Apollo moved on. Jim Webb had needed all of his persuasive abilities to convince Congress and the Bureau of the Budget to pay for enough Saturn V's to fly missions through Apollo 20. He had done so on the premise that no one knew how many flights would be necessary to meet Kennedy's challenge. Now that the first lunar landing had been accomplished sooner than anyone expected, there was enough hardware to fly 9 more lunar landings. Administrator Paine intended to make good on Webb's foresight. Pushing the handful of doubters aside, NASA had no intention of abandoning the moon. And if anyone wondered what would come from going back to the moon, they had only to be inside the windowless Lunar Receiving Laboratory at the Manned Spacecraft Center on the evening of July 25, 1969. In the Lunar Receiving Lab, 5 geologists dressed in white hospital-style clothes and caps stood around a vacuum chamber. A big, powerfully built technician reached into a pair of spacesuit arms attached to one side of the chamber to open a silvery container about the size and shape of a large tackle box. Inside, preserved in a lunar vacuum, were pieces of the moon. For the better part of a decade, geologists had labored to extend the disciplines of their science to an alien world by remote observation. What they had managed to learn about the moon from their telescopes and then the unmanned probes testified to the power of human intelligence. But they had always longed for the moment when they could probe the moon with their own state-of-the-art laboratory instruments, or simply with their own eyes. After long moments of effort, the box was opened. The technician removed a mesh covering and a strip of foil that was part of the scientific experiment and set them aside. Then he stepped away from the chamber and let the scientists look. With television carrying the event live, Harvard geologist Clifford Frondell peered into the chamber and blurted, "Holy S-word! It looks like a bunch of burnt potatoes." The rocks were so covered with charcoal-colored dust that the geologists couldn't tell anything about them. At this moment, the curiosity that gripped them was not scientific, but human. These were pieces of the moon. 2 nights later, the first sample to be cleaned was raised up inside the chamber while Frondell and the other scientists watched. Instantly, they recognized it as a piece of basalt. Familiar minerals glinted under the chamber lights. In the days and months to come, scientists would try to coax secrets of lunar history from the rocks and dust of the Sea of Tranquility, and this was just the beginning. Here's a clip of the examination of the moon rocks returned from Apollo 11.
As preliminary investigations continued under the direction of a number of scientists from academic institutions and government agencies, it became apparent that 4 general types of lunar materials had been collected. There was the lunar soil itself, composed of a variety of glasses mixed with crystal and angular rock fragments. There were fine-grained crystalline volcanic rocks characterized by minerals whose crystalline faces reflected in light, and by bubbles or vesicles which formed when the rocks were molten. There were somewhat coarser-grained volcanic rocks marked by irregular cavities or vugs which formed when the rocks were partly molten. Common to both types of volcanic rocks were the whitish mineral, which is known as plagioclase feldspar, the darker one, which is clinopyroxene, and the blackish one, which is ilmenite, or an iron titanium oxide. Finally, there were the breccias, comprising fragments of volcanic rock in a matrix of lunar soil. These were formed by impact hardening. Like all the rocks, the breccias are pockmarked by pits, formed by the impact of particles traveling at high velocity. In the scientists' preliminary studies of the lunar samples in the Lunar Receiving Laboratory, there were several significant findings. For instance, all the rocks are similar chemically, which points toward a family relationship. Although the components were known, the proportions are strange, suggesting either formative processes unknown to us on Earth or an unfamiliar bulk composition for the Moon. The soil and breccias contain large amounts of noble gases, that is, gases which do not combine readily in chemical reactions. Most of the gases were derived from the solar wind. In most of the rocks, there is evidence of shock. There is evidence of both lava flows and impact. Strangely, the breccias are far more magnetic than the volcanic rocks, the very material from which they were derived. The sandblasted appearance of the rocks indicates an erosion process about which there are major questions at present. There was no evidence that surface water had ever been present at the landing site. Neither was there evidence of any biological material. Perhaps the most interesting discovery was that the volcanic rocks are at least 3 billion years of age, dating back as far or perhaps further than the oldest rocks ever discovered on Earth. It would seem that if the lunar samples of the Apollo 11 landing do not themselves take us back to the origin of the Moon, then certainly rocks from other regions will. While the preliminary investigations produced new discoveries, they also led to a more intelligent distribution of the lunar material to the international team of 142 scientists who will conduct detailed investigations. Among those present when the first samples were distributed were Dr. Daniel Anderson, Lunar Receiving Laboratory Curator, Manned Spacecraft Center, and Dr. Paul Gast, Columbia University, Dr. Stuart Agrell, Cambridge University in England, Dr. Kurt Fredrickson, Smithsonian Institution, Dr. Dieter Heymann, Rice University. In their work, the scientists will study in detail such things as formative processes, physical properties, bulk chemistry, and the relative abundances of elements in primordial matter. From their studies and discoveries, basic new knowledge and understanding will emerge, and basic new questions, the beginning of what one investigator has called a new science.
The Moon had been transformed from a light in the sky to a world ripe for exploration, and the geologists had already picked out candidate landing sites for the landings to come, an ambitious and spectacular roster of missions. One team of astronauts would set down at the edge of a huge winding canyon called Schroeder's Valley, where perhaps 1 billion years of lunar history might be exposed, layer cake style, in the walls. Another would visit Marius Hills, a field of low, dome-like bumps which the geologist hoped might be small ancient volcanoes. The grand finale for Apollo 20 might be a descent into the yawning amphitheater of Copernicus crater. These missions would be scientific feasts, with 3-day stays on the surface and lunar roving vehicles, or perhaps one-manned lunar flyers. Their goal, as ambitious as any in science, was to answer the most basic questions about the Earth's nearest neighbor. How did the moon come to be? Was it really the cold, geologically dead world it seemed to be? Where did the moon come from? Solving these mysteries could open doors to even grander ones, for on that pockmarked, lifeless mass might be preserved the earliest history of the solar system, long erased on Earth. The scientists' fondest hope was that the moon would tell human beings how their own planet came to be. By November 1969, 3 astronauts were ready to open the door to these explorations with the flight of Apollo 12.
Throughout the ages, man has envisioned himself traveling to our nearest neighbor in the vast reaches of space, the moon. In this early sketch, he foresaw a lunar voyage in perhaps a sailing ship. It is interesting that on man's second journey to the surface of the moon, the crew likened their vehicles to sailing ships. The call signs selected for their spacecraft, Yankee Clipper and Intrepid. The mission emblem carried out the motif. The astronaut crew, 3 officers of the United States Navy. Man's first venture to set foot on another celestial body occurred in July 1969. Neil Armstrong and Edwin Aldrin proved that man could safely land on the moon, walk upon its surface, and perform useful work to add to our knowledge of the moon, the Earth, and the universe. The outstanding success of the epical first manned lunar landing brought us to the threshold of further exploration of the moon on follow-on Apollo missions. Apollo 12 was the first manned mission to be assigned the operational objectives of inspecting, surveying, and working on the surface of the moon. The 2 astronauts assigned to the landing mission rehearsed the lunar work many times on Earth. The astronauts were scheduled to leave their spacecraft twice while on the moon. During the first period of activity, they would set up the Apollo Lunar Surface Experiments package, conduct extensive photographic assignments, and collect soil samples near the spacecraft. During the second period, they were to locate the unmanned Surveyor 3 spacecraft, which soft-landed on the moon on the 17th of April, 1967, and transmitted over 6,000 pictures back to Earth. The astronauts were to remove several parts from the Surveyor, including its television camera, and return them to Earth for investigation. The 3 members of the Apollo 12 crew were Mission Commander Charles Conrad, Command Module Pilot Richard Gordon, and Alan Bean, the Lunar Module Pilot.
In Mission Control, the days and weeks after Apollo 11 were tough. The euphoria of the mission, coupled with the emotional intensity of the parties and the debriefing with the crew, was followed by a strange kind of emotional decompression, as if they were a diver who had come up from the pressure of the deep sea and had to gradually adjust to the sudden absence of that pressure. But Mission Control did not have much time to decompress, and there was a general feeling that they had pushed their luck, solving the Apollo 11 problems and then landing with only seconds of fuel. That was a lot tighter than anyone expected. Now the lunar program would focus on pinpoint landings, extending the duration and complexity of the surface activities, and mapping the moon. there was enough action for everyone. The systems controllers were the crew chiefs for the spacecraft. They were, by nature and training, tinkerers, mechanics. Living on government pay and raising a family was not easy, so many of them saved money by doing their own auto repair work, swapping tools and skills as necessary. One could identify the houses of the NASA employees who personally kept their old but well-maintained cars and motorcycles humming along by the oil stains on their driveway. Smooth running engines and harmonic rhythm of the valve train were music to their ears. Whether it was a car or a spacecraft, the systems people were the experts in diagnosis and providing quick fixes using the materials and tools at hand. They had a gut knowledge of why things worked and why they broke down. They grew up with the legacy of Aldrich, Brooks, Hannigan, Findle, and Aaron, the taskmasters who learned their trade in Mercury and Gemini. They were the kind of people you liked to have around when things unraveled. They worked like detectives, suspicious of anything that did not seem to fit, doggedly tracking down every glitch, relishing the opportunity to explain what was to the rest of us inexplicable. With Apollo 12, they would soon prove themselves the ultimate backup when their own systems let them down. Which leads us to the mission objectives for Apollo 12. After the successful lunar landing, it did not take the Apollo program office long to establish more and more demanding objectives for the next lunar flight. Apollo 12 began with 10 possible landing sites to choose from. This was reduced to 5, including Site 5, the Western Mare site preferred by the scientists, and the Surveyor 3 site. Chairman of the Apollo Site Selection Board, Major General Sam Phillips, chose the Surveyor 3 site as the target for Apollo 12, though the scientists unanimously rejected the choice because they considered the inert spacecraft to be an attractive nuisance that would divert the astronauts from more important work. However, the opportunity to recover some components from the Surveyor spacecraft for analysis and demonstrating a pinpoint landing was too good to miss, so the lunar module was targeted to set down next to Surveyor 3. Surveyor 3 was an unmanned spacecraft that landed on the moon about 3 years earlier. Surveyor 3 was now sitting in a 700-foot wide crater in the Ocean of Storms.
April 19, 1967, Surveyor 3 landed on the moon in a crater of Oceanus Procellarum, the Ocean of Storms. With Surveyor's electronic eye, we viewed the lunar surface. With its mechanical arm, we dug a small, shallow trench in the lunar soil. Now, on November 14, 1969, 31 months after Surveyor's landing, men were leaving the Earth to land on the Ocean of Storms. Charles Pete Conrad, Richard Gordon, Alan Bean, the crew of Apollo 12, the second manned landing on the face of the moon. Their target, the site of Surveyor 3.
The primary mission objectives of Apollo 12 included an extensive series of lunar exploration tasks by the lunar module crew, as well as deployment of the Apollo Lunar Surface Experiments package, which was to be left on the moon's surface to gather seismic, scientific, and engineering data throughout a long period of time. The experiments package included a passive seismic experiment, a lunar surface magnetometer experiment, a solar wind spectrometer experiment, a superthermal ion detector experiment, and a cold cathode ion gauge experiment. Deployment of the first Apollo lunar surface experiment package was high on the priority list since scientists had been disgruntled by the decision to fly a simplified package of surface experiments on Apollo 11. Geologists wanted the Apollo 12 astronauts to be somewhat more selective than their predecessors in collecting samples and stressed the importance of documenting, photographing, and describing them. They also preferred more rocks and less dust, if possible. Other Apollo 12 objectives included a selenological inspection, surveys and sampling in the landing areas, development of techniques for precision landing capabilities, further evaluations of the human capability to work in the lunar environment for prolonged periods of time, deployment and retrieval of other scientific experiments, and photography of candidate exploration sites for future missions. The astronauts also were to retrieve portions of the Surveyor 3 spacecraft, assuming their landing was close enough. And Apollo 12 would now have 2 surface EVAs. The flight plan for Apollo 12 was similar to that of Apollo 11, except 12 was to fly a higher inclination to the lunar equator and leave the free return trajectory after the second translunar mid-course correction. This first non-free return trajectory on an Apollo mission was designed to allow daylight launch and a translunar injection above the Pacific. It also allowed a stretch of the translunar coast to gain the desired landing site lighting at the time of lunar module descent. Additionally, it would conserve fuel and permit the Goldstone, California tracking antenna to monitor the lunar module descent and landing. The non-free return trajectory was designed so that in case a service module engine failure, the lunar module's descent engine could correct the resulting flight path for return to Earth. In addition, the Apollo 12 flight plan called for the lunar module ascent stage to provide a measured seismic stimulus for the Apollo lunar surface experiment package's seismic experiment. To perform this after the lunar expedition, the crew would return to the command module and service module as usual and undock with the lunar module ascent stage. Then the ascent module would perform a controlled burn of its remaining propellants, causing the stage to crash into the moon, thus providing a measurable seismic shock impulse. Now moving on to the astronauts. Apollo 12 had an all-Navy crew. The commander was Charles Pete Conrad, the command module pilot was Richard F. Gordon, and the lunar module pilot was Alan Bean. Unlike Apollo 11, the Apollo 12 prime crew were a team of close friends from well before they joined NASA. All were Navy pilots, and they had been shipboard cabin mates flying F-4s off the carrier USS Ranger. Originally, the lunar module pilot for Apollo 12 was listed to be Clifton Williams, while Alan Bean was scheduled for the Apollo Applications program that would follow the moon landings. At the time, Conrad and his crew were training for the first lunar landing as backup crew, but the game of musical chairs was still playing and the music stopped again on October 5, 1967. Clifton Williams was flying home to see his dying father in Mobile, Alabama, when his T-38 jet went into an uncontrollable roll and crashed. The crash was caused by a mechanical failure. The failure caused the flight controls to stop responding, and although Clifton activated the ejector seat, it did not save him as the plane was too low. Alan Bean couldn't believe his ears when he heard his old friend Pete Conrad asking him to join his crew as lunar module pilot. Lastly, I want to cover the names and insignia. Pete Conrad was asked how they selected the names for the command module and the lunar module. This is what he said, quote, "North American Rockwell built the command module, and we had people out there submit names for the spacecraft with 25 words why they chose that name. We had them do the same at Grumman Aircraft for the lunar module. I wanted to let the people that built them name them. Yankee Clipper was named after the U.S. Clipper ship, one of the first U.S. ventures around the world in the maritime world. The guys at Grumman named the lunar module Intrepid based on the Webster's Dictionary definition of the word." End quote. The Apollo 12 mission insignia shows the crew's Navy background. It features a clipper ship arriving at the moon, representing the command module Yankee Clipper, and to anticipate the spacecraft providing a means of traveling between the planets, the way ships opened up the seas to commerce. The ship trails fire and flies the flag of the United States. The mission name, Apollo 12, and the crew names are on a wide gold border with a small blue trim. Blue and gold are traditional U.S. Navy colors. The insignia has 4 stars on it, one for each of the 3 astronauts who flew the mission, and one for Clifton Williams. Salutations from the foothills of North Carolina. This is Michael Annis, your host, and I wanted to say thanks for listening to episode 235 of the Space Rocket History Podcast, entitled Apollo 12 Introduction. Hope you enjoyed this episode. It was a pleasure to bring it to you. I want to give a big shout out to all my longtime listeners. Thanks for staying subscribed, and extend a warm welcome to my new listeners. I'm glad you're here. In case you hadn't heard, there is a new RSS feed for the first 28 episodes of the podcast. You can find it on the homepage on the right side of the page. This means that the first 28 episodes are once again available on iTunes, Stitcher, Google Play, and all your favorite podcatchers. To find the archive episodes there, search for Space Rocket History Archive. My server plan allows me to add 100 megabyte of episodes per month, so I plan to get some more archive episodes up in December. Today, we salute my Patreon donors. Patreon donors give a small amount monthly to support the podcast. Thanks, Patreon donors who honored your pledge this month. I had several afterthoughts about this week's episode. First, I want to give credit to a few of the sources I used for this episode, and that would be Andrew Chaikin's A Man on the Moon, Gene Kranz's Failure is Not an Option, and the Apollo 12 Flight Journal. As you probably remember, Apollo 12 was the only Apollo launch that I got to witness in person, so that automatically makes it one of my favorites. I will give the details of what I remember about the launch when we do the launch episode. But don't expect too much. I was only 9 years old at the time, and my memories are still a little foggy, if you catch my drift. I'm very excited to kick off the Apollo 12 mission. It will have more time on the moon, 2 EVAs, more science, and the cool factor of finding Surveyor 3. But be prepared for a few surprises on Apollo 12. I also want to mention that the backup crew for Apollo 12 was Dave Scott, Al Warden, and Jim Irwin. They will become the prime crew for Apollo 15. Well, could you believe the plan Nixon's Space Task Group recommended? A 12-man space station and a reusable space shuttle as early as 1975. By 1980, the station would have grown into a 50-man space base. 5 years later, there would be 100 men in orbit. Meanwhile, there would be a base in lunar orbit by 1976, with a base on the moon in 1978. Then, as early as 1981, the first manned expedition to Mars would depart from Earth. Absolutely amazing. The opportunities we had in 1969 with that Saturn V rocket. Now, I'm sure the dates would have slipped, but I believe all those things could have been accomplished by 2017. If only NASA would have continued to have been funded at the level they were in 1965. Okay, I have posted some pictures and the audio for this episode on my homepage, spacerockethistory.com, and I hope you check that out. I was very pleased to receive several new donations to support the podcast over the past week. Matthew P. from Minnesota donated at the Mercury level. Stephen L. sent in another donation this year, moving him to the Gemini level. Jake W. donated at the Mercury level. Killian M. from Germany donated at the Vostok level. And Jeremy S. pledged on Patreon at the commercial level and wanted to be identified with Orbital ATK. You may remember that the commercial level, which is $90, you can choose which commercial company you would like to be identified with, and Jeremy chose Orbital ATK because he once worked there. I thought that was really cool. It must have been fun working there at Orbital ATK. And Jeremy also sent in a bonus donation. Thank you very much, Jeremy. I sincerely do appreciate that. Now, over the transition of November to December, we lost one Patreon and we gained one Patreon. So the total remains at 147, the highest number we have had so far. Our goal is 150 by the end of the year. We only need 3. Will we accomplish this? Maybe. Our total donors this year, that is Patreon plus one-time donors, has reached 303. I got so excited that we had reached the 300 goal, I had to tell Walter Cronkite about it, and here's what he said.
The floor is terrific. The building's shaking. This big glass window is shaking. We're holding it with our hands. Look at that rocket go.
No kidding, folks. This is fantastic to have met a goal. I think that may be the first time we've actually met a goal for an annual donation level. That is fantastic, and I want to thank each and every one of you donors. I sincerely appreciate it. For those of you who are enjoying the content provided here and who have not donated yet in 2017, please consider supporting the podcast if you're financially able. Keep in mind, Space Rocket History is entirely listener-funded. There are 3 easy ways to make a donation. You can go to the homepage and click on the orange button to make a one-time donation, or if you prefer, you can become my patron at Patreon by clicking on the Patreon link below the orange donate button, or you can mail me a check. To do that, just email me, Mike at spacerockethistory.com, and I will give you my address. Now, I mentioned this last week, and I wanted to make sure everybody got a chance to hear it. This is regarding longevity rewards. This is a special time of the year. At this time, you can perform what I like to call the emoji maneuver. Let's say you haven't donated yet this year. If you make a donation now, before the end of the year, and make a donation in January of 2018, you can earn your rocket emoji longevity award that will be put beside your name on the donors list in less than 2 months. Or you could become my Patreon now and remain my Patreon in January, and you would automatically earn your rocket emoji. This opportunity only happens at the end of the year, so think about that. Now, for those of you who have already donated for 2017, I appreciate it, and I have an item to give away this week. It is the NASA 3 1/2 inch diameter meatball sticker. To select a winner, I gave each donor a number. I put the range in Google's random number generator and got the number for Pierluigi. Pierluigi, I'm sorry if I mispronounced your name, but if you would email me, mike@spacerockethistory.com, and tell me your address, I will mail this meatball sticker out to you. I have several more of these stickers, so we'll have a new drawing for the 2017 donor group next week. And next year, I have got something really nice to give away, or at least I think it's really nice. So next year, we've got some good prizes to draw for the donors who support the podcast. I was pleased to see the podcast receive one new anonymous 5-star rating on iTunes, and I want to thank whoever did that. I certainly do appreciate it. And this is the end of content for this episode. If you care to listen to my off-topic thoughts, just continue, or you can switch to the next podcast. Thanks for sticking around, folks. I hope you enjoyed that episode. Next week, we will begin covering the Apollo 12 crew biographies. Now, at this point in the podcast, I usually give out some statistics, but there's a problem. My podcast host, Blueberry, notified all its podcasters that downloads from devices running iOS 11, which is most iPhones and iPads, would no longer be counted in my total downloads. So my statistics are no longer valid. They're leaving out like 52% of my audience. They're not counting. 52% of my audience use iPhones and iPads, mainly iPhones. So I had noticed over the past week or two that the downloads were going down, and I couldn't figure out why it was. At first I was attributing that to the Thanksgiving Day holiday. But that was over, and the downloads were still staying down. Now, I understand what is going on. They've just not counting over half of them. So, that's a kind of a problem that just is not acceptable to me. So, as much trouble as it is, I'm going to look for another podcast host that doesn't have this problem. If any of you listening to the podcast now, if you are podcasters or you know a lot about it, and you have a host that doesn't have a problem with counting iOS 11 downloads, please let me know. Mike@spacerockethistory.com. I really hate to go through all the trouble of moving to another host, but I would like to have my stats correct. I'm sure those that have advertisers on their site for their podcast would like to have correct stats as well. Cutting your downloads in half is just not acceptable. So, if you know somebody good, shoot me an email. Okay, in personal news, guess what came in the mail yesterday? It was the Saturn V Lego kit that I got for $119 on the Amazon website. Now, I haven't opened it up. Actually, it came in. Another box came in yesterday, and I went out to open it up and because I thought it was my Apollo Saturn V, and it turned out to be other Christmas gifts to me that were going to be a surprise that my wife had got. Boy, did I get in trouble for that one. Can't you read? It's my name on that box. Why didn't you open that box? Oh, mercy. That lasted a long time, too. You aren't going to get any surprises for Christmas. But I really thought it was my Lego box, that Lego Saturn V. But anyway, I think we're good now. But we're excited to start building it. I hope to start building it Saturday with my grandsons. Now, I did have a listener email me and gave me a link that said that the Saturn V Lego kit is back in stock at the Lego store online, and it's at $119. So if you're looking for one of those Saturn V's, you might want to get over there soon, because it will sell out pretty quickly at that price, probably. Okay, that's all I have for this week. Hope to have episode 236 posted by next Thursday. So long for now.